There are things the universe does not announce. No warning, no signal, no sound. Just the sudden, overwhelming presence of something so vast, so indifferent, so brutally silent that the human mind, trained by evolution to survive on a small, warm, noisy planet, simply does not have the architecture to process it without cracking at the edges. 4 human beings flew beyond the moon, not metaphorically, not in simulation, not in the comfortable abstraction of a photograph taken 50 years ago by someone else. 4 living, breathing, warm-blooded human beings strapped themselves into a capsule no wider than a modest living room, rode a column of controlled nuclear fire into the vacuum of space, and kept going, past the orbital shell where the International Space Station glides in careful safety, past the comfortable zone where rescue is theoretically possible, past the gravitational cradle that has held every human being who has ever lived, and emerged on the other side of the moon. They saw something out there. Not an alien, not a ghost, not a conspiracy etched into the surface of a dead world. What they saw was far more destabilizing than any of those things, because it was real, measurable, documented, and it violated something fundamental about the way human beings believe they understand the cosmos. The Artemis II mission was supposed to be a triumph, a proof of concept, a demonstration that humanity had reclaimed its rightful position as a spacefaring species. And in many ways, it was exactly that. The Orion capsule performed. The Space Launch System performed. The crew, Reid Wiseman, Victor Glover, Christina Koch, and Canadian astronaut Jeremy Hansen, performed with the precision and composure of people who had trained for years inside the simulation of an experience that no simulation can actually prepare you for. But simulations end, and then the real thing begins. There is a moment, documented in the mission telemetry and confirmed in post-flight debriefs, when the capsule cleared the lunar limb and the crew was exposed, fully, completely, without atmosphere or magnetosphere or the thin psychological buffer of Earth's proximity, to deep space. Not near-Earth space, not the comfortable orbital neighborhood. Deep space, the kind of space where the sun shrinks, where the Earth becomes a pale, fragile marble hanging in a blackness so total it has weight. One of the crew members later described it as the moment the universe became personal. That description is more precise than it sounds, because what they encountered in that exposure, the radiation environment, the psychological phenomenon scientists now call cosmic awe syndrome, the disorienting geometry of a sky with no horizon, no atmosphere, no scattering of light, left marks. Not metaphorical marks, physiological marks, neurological signatures, data points that NASA engineers and space medicine researchers are still working to fully interpret. This is not a story about what went wrong. This is a story about what went right, and why that is somehow more unsettling. To understand what the Artemis II crew experienced, you have to first dismantle something you have believed your entire life. You have believed, in a deep and unexamined way, that space is empty. This is one of the most consequential misconceptions in the history of human thought. Not because it is entirely wrong, but because it is wrong in precisely the ways that matter most. Space is not empty. Space is filled with things that have no obligation to behave according to the intuitions evolution built into you. It is filled with radiation moving at the speed of light, with magnetic field lines twisted into geometries that have no name in human language, with gravitational gradients so subtle they are invisible until they are not, with quantum fluctuations at the Planck scale that cause particles to blink into existence and vanish before any instrument can confirm they were ever real. The vacuum of deep space is not the absence of things. It is the presence of everything that has no physical form. Energy without mass, force without origin, potential without substance. When the Orion capsule crossed the boundary of cislunar space and moved into the translunar trajectory that would carry the crew around the far side of the moon, the crew did not feel the boundary. There was no sensation, no sound, no change in temperature, no shudder in the hull. The capsule simply continued its arc through the void. And the universe outside the windows continued its absolute geological silence. But the instruments felt it. The radiation monitors embedded in the capsule walls, sensors designed to detect and quantify the particle environment through which the vehicle was traveling, began registering numbers that, while within predicted ranges, carry a weight that no pre-flight briefing fully communicates. Because numbers on a screen and the reality those numbers represent are two entirely different categories of experience. A radiation physicist sitting in a control room in Houston can look at a dosimetry readout and feel nothing. The person inside the capsule, surrounded by that radiation, breathing recycled air 400,000 kilometers from the nearest hospital, feels something else entirely. The primary source of that radiation is the sun, but not the sun you know from a summer afternoon. Not the warm, generous, life-giving star that ripens fruit and warms skin and makes shadows dance on grass. The sun that exists beyond Earth's magnetosphere is something categorically different. It is a thermonuclear reactor, 432,000 miles in diameter, converting 600 million tons of hydrogen into helium every single second, releasing energy in the form of photons, protons, electrons, and heavier ions that travel outward in all directions at velocities approaching the speed of light. The solar wind, the constant stream of charged particles flowing from the sun's corona, moves at roughly 400 kilometers per second on average. During a solar energetic particle event, those speeds increase dramatically, and the particle energies rise to levels that can penetrate spacecraft shielding, penetrate tissue, penetrate the double helix of DNA itself, and leave breaks in the molecular code that took 4 billion years of evolution to write. Earth's magnetosphere, the invisible magnetic shield generated by the planet's rotating iron core, deflects the vast majority of this bombardment. It is, in the most literal physical sense, the reason life exists on this planet. It is the reason you are able to sit wherever you are right now and think and feel and breathe without being irradiated into cellular incoherence. You have never spent a single conscious moment outside its protection. Neither had any human being alive when the Artemis II crew departed. And then, for the first time in over 50 years, human beings left it behind. The Apollo crews experienced this too, but the Apollo program operated in an era before the tools existed to fully characterize what the human body was experiencing at the cellular level. The astronauts came back changed. Some reported visual phenomena, flashes of light behind closed eyes caused by cosmic ray particles passing through the vitreous fluid of the eyeball and triggering the optic nerve directly, bypassing the retina entirely. They called them light flashes. The medical literature calls them cosmic ray visual phenomena, whatever you call them. They are the universe reaching inside the human skull and touching the brain with a particle that has been traveling across interstellar space for millions of years, carrying energy from a supernova that detonated before the Earth existed, arriving at the precise moment when a human eye happened to be in its path. The Artemis II crew reported the same phenomenon, all 4 of them, Every closed eye in that capsule was periodically illuminated from within by the passage of cosmic rays. Not imagined, not psychological artifacts of stress and isolation, but real photonic events caused by real particles from real sources billions of light years away. Intersecting with the trajectory of a small metal capsule carrying 4 members of a species that has existed for approximately 300,000 years on a planet that has existed for 4.5 billion. Let the scale of that sink into you slowly, the way cold water sinks into stone. A particle born in a supernova explosion in a galaxy so distant, its light takes 2 billion years to reach us. A galaxy that does not have a name in any human language, that has never been observed by any telescope, that exists in a region of the universe we will never reach, whose stars were born and died before the first multicellular organisms appeared on Earth. That particle crossed the intergalactic void, entered the Milky Way, crossed the spiral arm that contains our solar system, passed through the heliosphere, threaded between the planets, and struck the retina of a human being named Christina Koch at a velocity indistinguishable from the speed of light. And she saw a flash of blue-white light behind her closed eyelids, and she was the first woman in history to see it from that distance. That is not a metaphor. That is physics. And physics, at this scale, begins to feel indistinguishable from something older and stranger than science. Beyond the radiation environment, beyond the particle physics of the interplanetary medium, there is something that the mission data documents with equal precision, but that is far harder to quantify. The visual experience of deep space itself. Human vision evolved in an environment of scattered light. The atmosphere scatters sunlight in all directions, filling the sky with a diffuse, sourceless illumination that makes shadows soft, that gives distance its haze, that creates the graduated transition from bright to dark that human brains use to judge depth, distance, and scale. Every painting ever made, every photograph ever taken, every landscape ever observed by human eyes operates within this framework of scattered atmospheric light. It is so fundamental to human visual perception that we do not notice it any more than a fish notices water. In deep space, there is no scattering. Light in deep space travels in straight lines of perfect, absolute geometry. There are no gradients. There is no haze. There is no softening of edges or blending of shadows. Objects are either in direct sunlight, illuminated with a harshness that makes the word bright seem inadequate, a light that casts shadows with edges as sharp as a surgical incision, or they are in darkness so complete it has a texture. The stars do not twinkle. They are points of light with no atmosphere to distort them, geometrically perfect, unwavering, with colors that the human eye can actually detect because there is no atmospheric absorption to filter them. The pale blue of massive young stars, the deep amber of aging giants, the cold white of stellar remnants, all of them burning simultaneously in a sky that exists in every direction at once, above and below and to all sides, because in space there is no above and no below. And the concept of a horizon, the concept that has oriented every human being who has ever lived, the line that tells your brain where safe ground ends and open sky begins, does not exist. There is no horizon in deep space. This is not a poetic statement. It is a neurological crisis in slow motion. The human vestibular system, the biological gyroscope housed in the inner ear that tells you which way is down, that orients your body in space, that gives you the fundamental sense of having a position in the world, loses its reference point in microgravity. This is well documented. astronauts adapt. But the adaptation takes time, and during the transition, the brain receives contradictory information from different sensory systems. The eyes say there is no up or down. The vestibular system, trained by a lifetime of gravity, insists that there must be. The result is a form of spatial disorientation that ranges from mild and quickly resolved to profoundly destabilizing depending on the individual nervous system. For the Artemis II crew, this disorientation was compounded by something that Apollo-era astronauts had reported, but that modern neuroscience is only now beginning to model with precision. The cognitive effect of looking at Earth from a distance, great enough that it fits entirely within the field of vision. From the surface of the Earth, or from low Earth orbit, the planet is not a thing you can see. It is the thing you are on. It is the ground beneath your feet, the horizon at the edge of your sight, the context in which everything else exists. Even from the International Space Station at 400 kilometers of altitude, the curvature of the Earth is visible, but the planet itself is not. You can see a portion of it, a sweeping arc of blue and white and brown, but it is still too large to perceive as an object. It is still a surface, still a ground, still a place. From 250,000 kilometers, the distance at which the Artemis II crew observed the Earth during their outbound transit, the planet fits inside a circle you could cover with your outstretched thumb. The entire Earth, every ocean, every continent, every mountain range and desert and ice sheet, every city with its lights, every human being who has ever lived except for 4. Every ecosystem, every species, every language, every war, every love affair, every cathedral, every landfill, every hospital, every graveyard. The complete, total, unabridged inventory of everything that has ever mattered to any member of the human species, compressed into a disk of color small enough to occlude with a human thumb. Edgar Mitchell, the Apollo 14 astronaut, described the experience of seeing Earth from the Moon as an instant global consciousness, a sudden, overwhelming understanding that the categories and divisions that structure human life on the surface are not real in any fundamental sense, that the borders and the nations and the ideologies and the conflicts are features of a story told by creatures too small to see themselves from the outside. He called it an epiphany. He spent the rest of his life trying to find a language adequate to describe it. The Artemis II crew had the same experience. The debriefs confirm it. Every one of them described a version of the same cognitive event, a moment of seeing the Earth not as home, not as ground, not as context, but as object, as a thing floating in a void, as a fragile, luminous, impossibly beautiful sphere of chemistry and coincidence, held in its orbit by the curvature of space-time. Warmed by a star, it happens to orbit at the precise distance required for liquid water to exist on its surface. Protected by a magnetic field it happens to have, because its core happens to be composed of the right elements in the right proportions. And recognizing, with a clarity that no classroom and no textbook and no photograph has ever produced in any human mind, that none of this was inevitable. The Earth did not have to be here. Life did not have to evolve. You did not have to exist. The probability of the specific chain of events required for a conscious creature to look out a window 400,000 kilometers from home and feel overwhelmed by beauty is so vanishingly small that the number has more zeros than the human brain can hold in working memory simultaneously. And yet, here it happened. Here, it was witnessed. Here, 4 human beings floated in a metal capsule in the absolute darkness of interplanetary space. and looked at the small blue light that made them, and felt not triumph, not conquest, not the pride of technological achievement, but something closer to vertigo, something closer to grief, something that has no precise name in English or in any other language, because no language was built by creatures who had seen what they had seen. The universe is not indifferent to you. It is simply operating at a scale for which indifference and devotion are the same thing. There is a place no human being had visited in more than 50 years. Not a place on any map. Not a place with a name that appears in any atlas or any travel guide or any document that circulates among ordinary human beings living ordinary human lives on the surface of a planet they have never truly seen from the outside. It is a place defined not by geography, but by geometry, by the precise angular relationship between a spacecraft, a moon, and a star. And it is called, in the clinical language of orbital mechanics, the far side lunar flyby corridor. When the Orion capsule swung around the limb of the moon and entered the shadow of the lunar far side, the crew passed through a boundary that has no physical marker and no sensory announcement. There was no change in the quality of the darkness. There was no sound. There was no turbulence. The capsule simply continued its trajectory, governed by the same equations Isaac Newton wrote in the 17th century, and the Earth disappeared. Not dimmed, not faded, not retreated to a smaller point of light on the horizon. Disappeared. For the first time since the Apollo 17 crew made the same passage in December of 1972, human beings were on the far side of the moon, the hemisphere that is faced away from Earth for the entire 4.5 billion years of the moon's existence. The side that no human eye had ever seen before in 1968. The side that no radio signal from Earth can reach. The side that sits in a silence so complete that the word silence itself feels inadequate to describe it. In that corridor, the crew of Artemis II had no communication with Earth. Not degraded communication, not intermittent communication, no communication. The signal does not bend around the moon. Radio waves, like light, travel in straight lines, and the moon's bulk, 3,474 kilometers in diameter, a sphere of rock and ancient magma 4.5 billion years old, sat between the capsule's antenna and every receiver on Earth, blocking the signal with the absolute completeness of a stone wall placed between a whisper and the ear that was meant to hear it. For those minutes, the precise duration depending on the trajectory's geometry, but long enough to be felt in the body as well as the mind. The 4 members of the crew were the most isolated human beings in the history of the species. More isolated than any explorer who has ever walked into an unmapped wilderness, because every explorer who ever lived still shared a planet with other human beings. More isolated than any sailor who ever lost sight of shore, because every sailor who ever lost sight of shore was still breathing the same atmosphere, still connected by the invisible thread of a shared biosphere, still subject to the same weather systems and the same gravitational field as the people waiting for them at home. More isolated than any prisoner in solitary confinement, because even solitary confinement occurs within a structure built by human hands on a planet teeming with billions of lives. In the far side corridor, the nearest human being was not on the other side of a wall. The nearest human being was not on the other side of an ocean. The nearest human being was on the other side of the moon. And then beyond that, at the end of a radio signal that would take more than a second to travel the distance. 250,000 miles of vacuum and silence and a cosmic radiation separating 4 people from the entire population of a species. This is the kind of isolation that has a texture. Psychologists who study extreme environment psychology Researchers who spend careers analyzing the cognitive and emotional states of people in Antarctic research stations, in submarine deployments, in simulated Mars mission habitats, use a term for the psychological response to radical isolation from one species. They call it the overview effect's shadow. If the overview effect is the expansion of consciousness that comes from seeing the Earth as a whole, its shadow is the contraction that follows. The sudden, cellular awareness of how small the thread is that connects any individual human consciousness to the fabric of human civilization. In normal life, that thread is invisible because it is everywhere. Language is that thread. Architecture is that thread. The sound of another human voice. The presence of a face. The knowledge that if you fell, someone would hear you. All of it is the thread, woven so densely into the texture of daily existence that you cannot see it any more than you can see the air. In the far side corridor, the thread became visible by its absence, and its absence felt like something. The crew did not panic. These are not people who panic. They were selected from thousands of candidates through a multi-year process designed to identify the specific combination of psychological resilience, technical competence, and cognitive flexibility required to function at the edge of what human beings can endure. They had trained for this moment. They had simulated it. They had discussed it with psychologists and philosophers, and with each other in the quiet hours before launch, when the simulations were done. And the reality of what they were about to do settled into the body like a cold weight. But training is a model of an experience, and the experience of being on the far side of the moon, in a capsule surrounded by the absolute silence of deep space, with no signal from Earth and no horizon and no reference point for up or down, with the far side lunar surface visible through the windows in the harsh, unscattered sunlight of a sky without atmosphere. Training does not reach that place. Training stops at the door and waits outside. What they saw through those windows deserves a moment of sustained attention. The far side of the moon is not the dark side. This is a persistent misconception rooted in a poetic phrase that is physically incorrect. The far side receives exactly as much sunlight as the near side. The moon rotates on its axis once per orbit, meaning both hemispheres experience a lunar day and a lunar night of approximately 2 Earth weeks each. The phrase, dark side of the moon, refers to a cultural and psychological darkness, not an astronomical one. When the Artemis II crew was in the far side corridor, portions of that hemisphere were in full sunlight. And what they saw in that sunlight was a surface that differs from the near side in ways that planetary scientists still do not fully understand. The near side of the moon, the face that has watched humanity for the entirety of human existence, the face that appears in mythology and poetry and religious iconography across every culture that has ever existed on Earth, is relatively smooth. Its dark regions, called Maria, are vast, ancient lava plains that formed when the young moon's mantle was still partially molten, and asteroid impacts punched through the crust and flooded the impact basins with magma that cooled over millions of years into the flat, dark plains that give the near side its familiar face. These Maria make up roughly 30% of the near side surface. The far side has almost no Maria. Less than 1% of its surface is covered by those ancient lava plains. The far side is almost entirely covered by the ancient, heavily cratered highlands. The original crust of the moon, pounded by billions of years of impact events into a surface of extraordinary complexity and age. a geological record of the solar system's violent youth preserved with almost no modification, because the moon has no atmosphere, no weather, no plate tectonics, no erosion of any kind, except the slow, patient grinding of micrometeoroid impacts, and the thermal expansion and contraction of rock cycling through 2-week days and 2-week nights. The far side is older than the near side in the way it looks. It wears the history of the early solar system on its face, without apology and without disguise. Every crater visible through the capsule's windows represents a collision, an asteroid or comet impact that released energy measured in megatons or gigatons or teratons, that vaporized rock, that sent ejecta flying across hundreds of kilometers, that reset the local geology and left a scar that will persist for billions of years, because there is nothing on the moon capable of healing it. The largest visible feature of the far side, the South Pole Aitken Basin, is one of the largest confirmed impact craters in the solar system. It stretches 2,500 kilometers across and plunges 13 kilometers deep in places, a wound in the lunar crust so catastrophic that it exposed material from the moon's mantle. Rock that formed in the interior of the moon during its earliest existence and has not seen the surface since. The impactor that created it was an asteroid or protoplanetary body, perhaps 170 kilometers in diameter, striking at a velocity of perhaps 10 to 15 kilometers per second, releasing energy equivalent to billions of nuclear weapons, detonating simultaneously in a fraction of a second. When the Artemis II crew looked at the rim of that basin from the altitude of their flyby trajectory, the capsule passing at its closest approach within a few hundred kilometers of the lunar surface, they were looking at geology that predates the existence of the oceans on Earth. They were looking at the scar of a collision that occurred when the solar system was still young and chaotic and violent in ways that make the current era of planetary stability seem almost miraculous by comparison, because that is what the current era is, a miracle of stability. The solar system's early history, the period planetary scientists call the Late Heavy Bombardment, a phase that ended approximately 3.8 billion years ago, was a time of such relentless, sustained planetary violence that the concept of a habitable surface was essentially meaningless. The inner planets were being struck by planet-sized objects with a frequency that kept their surfaces molten, that reset any geological progress, that made the emergence of life not merely unlikely, but physically impossible. The scars of that era are preserved on the moon with extraordinary fidelity, precisely because the moon lacks the geological processes that erase them on Earth. The lunar surface is an archive, a library of catastrophe, written in the language of rock and void. The Artemis II crew read that library with their eyes, and the reading changes you in ways that are difficult to articulate, but impossible to dismiss. There is a cognitive phenomenon that researchers at the University of California and independently at several European space medicine institutions have documented in astronauts who have had extended exposure to deep space and to the lunar environment. It is not classified. It is not hidden. It is published in peer-reviewed journals in the dry, careful language of scientific literature. But the dry language does not communicate the weight of what it describes. The phenomenon involves a reorganization of what psychologists call the threat detection hierarchy, the unconscious ranking system the human brain uses to prioritize which potential dangers deserve immediate attention and which can be deferred on Earth. This hierarchy is calibrated by evolution for the threats that existed in the environment where the human brain evolved: predators, social conflict, resource competition, disease. the physical dangers of a world governed by weather and gravity, and the unpredictability of other human beings. These are the threats the brain knows how to process. These are the fears that have names and shapes and durations. In deep space, the threat detection hierarchy encounters something it was not designed to process. A threat that is total, omnidirectional, invisible, and without any possible behavioral response. You cannot fight the vacuum. You cannot negotiate with cosmic radiation. You cannot run from the gravitational field of the moon or the thermal extremes of a space environment that swings between 120 degrees Celsius in direct sunlight and minus 170 degrees in shadow, sometimes within meters of each other, sometimes within seconds as a rotating surface passes through the terminator line between lunar day and lunar night. The threat is everything, everywhere, always, and the only response available is the capsule. A volume of pressurized air and engineered materials representing the complete sum of humanity's technological capability to create a habitable bubble inside an environment that is fundamentally, categorically, completely hostile to the existence of biological life. When the brain's threat detection system encounters this situation, total threat, no behavioral response, complete dependence on technology, it does something unexpected, something that the researchers who study it describe with a careful neutrality that barely contains the enormity of what they are observing. It goes quiet. Not numb, not shut down, not the dissociation of trauma. It goes quiet in the way a room goes quiet when something enters it that commands absolute attention. The neural noise that constitutes ordinary conscious experience, the background hum of social anxiety and financial worry and interpersonal friction and the thousand small irritations that structure a human day, falls away, not gradually, suddenly, as if a volume knob were turned to zero. And in that quiet, something else becomes audible. The crew of Artemis II described it in different ways in their individual debriefs. Reid Wiseman said it felt like the universe was making a point he had almost understood before, but never quite reached. Victor Glover said it felt like grief and gratitude arriving simultaneously, indistinguishable from each other. Christina Koch said it felt like the first time she had ever been fully present. Not present in the mindfulness practice sense, but present in the sense of being a physical object in physical space, made of atoms, surrounded by atoms, part of something so large that the word large was no longer functional. Jeremy Hansen, the Canadian astronaut making his first space flight, said something that the mission psychologists found particularly significant. He said that in the silence of the far side corridor, with no signal from Earth and the cratered surface of the moon filling one window and the absolute black of the interplanetary void filling another, he had a thought that he could not dismiss even after returning to Earth and resuming the ordinary grammar of human life. He thought, we were never meant to go here, not as a statement of prohibition, not as a theological claim, as an observation about biological architecture, as the recognition that the body sitting inside that capsule, his body, with its calcium bones and its iron-rich blood and its water-filled cells and its evolutionarily ancient nervous system, was built for a world that does not look like this, was built by a process, evolution, that optimized for survival on a warm, wet, atmospheric planet with a horizon and a sky, and a predictable cycle of light and dark, and a gravitational constant that the inner ear has known since birth. That body, in that place, was an impossibility made real by technology. A biological creature from one world visiting conditions that belonged to a different category of existence entirely. not another planet, not another star. Just the space between things. The vast, cold, silent, beautiful, indifferent space between things that makes up the overwhelming majority of the volume of the universe. We are the exception. Life is the exception. Warmth is the exception. The rule is what the Artemis II crew floated through in the far side corridor. Cold, dark, silent, ancient, and so perfectly, devastatingly, transcendently beautiful that 4 trained astronauts with advanced degrees and thousands of hours of flight experience and every psychological preparation that modern science could provide looked at it through the windows of their capsule and felt, each in their own way, the specific mixture of awe and terror and love and smallness that has no name, because no name has ever been needed for it before. Before now. Before them. Before humanity looked at the void from the inside and recognized something of itself in the looking. The human body was not consulted when the decision was made to send it to space. Evolution. The blind and patient process that spent 4 billion years assembling the biological machinery that walks and breathes and thinks and feels, optimized for one environment and one environment only. The surface of a planet with a specific gravity, a specific atmospheric pressure, a specific electromagnetic environment, a specific set of biological threats and biological resources. Every system in the human body is a solution to a problem that existed on that surface. The heart pumps blood upward against gravity because gravity exists. The bones maintain their density because weight-bearing loads demand it. The immune system patrols for microorganisms because microorganisms exist in the shared biosphere. The circadian rhythm synchronizes to a 24-hour cycle because that is how long it takes the Earth to rotate once on its axis beneath a sun whose light tells the body what time it is. Remove any of those conditions, and the body begins, immediately and without hesitation, to adapt, which is a clinical way of saying it begins to fall apart in the specific directions that the missing conditions no longer prevent. In microgravity, the heart, freed from the obligation to pump blood upward against a gravitational gradient, shifts its fluid distribution toward the upper body and the head. Astronauts in the early days of their missions describe feeling perpetually congested, as if they have a head cold that never fully resolves. This is not congestion in the respiratory sense. It is the cephalad fluid shift, blood and interstitial fluid migrating toward the head in volumes that the cardiovascular system was never designed to manage, without the counterbalancing force of gravity pulling it back toward the legs and feet. The face swells subtly. The sinuses fill with pressure. The intracranial pressure, the pressure inside the skull, surrounding the brain, rises. This matters enormously. And it matters in ways that the space medicine community is still working to fully understand. Elevated intracranial pressure is not a trivial condition. On Earth, sustained elevation of intracranial pressure is a medical emergency, a symptom of hemorrhage or tumor or meningitis or any number of conditions that threaten the brain's ability to function. In space, it is a chronic background condition that persists for the duration of the mission, fluctuating with physical activity and sleep position and fluid intake, but never resolving to the baseline that gravity maintains automatically on the ground without any biological effort whatsoever. The consequence that concerns space medicine researchers most urgently, the consequence that has generated the most significant body of post-mission research and the most sustained debate within the aerospace medicine community, is what happens to the eyes. The optic nerve sits inside a sheath of cerebrospinal fluid that connects directly to the intracranial space. When intracranial pressure rises, That fluid pressure transmits directly to the optic nerve sheath, pressing against the back of the eyeball with a force that, over time, reshapes the eye itself. The globe of the eye, the roughly spherical structure whose precise shape determines whether light focuses correctly on the retina, flattens slightly under this sustained pressure. The optic disc, where the optic nerve connects to the retina, develops swelling visible on imaging. The result is a condition called spaceflight-associated neuroocular syndrome, and it affects a significant fraction of astronauts who spend extended time in microgravity. The vision changes, not always dramatically, not always permanently, but measurably, documentably, in ways that can be quantified with the precision instruments of modern ophthalmology. Astronauts who had perfect vision before a long-duration mission sometimes need reading glasses afterward. The focal length of the eye has changed. The shape of the structure through which they perceive the world has been altered by the simple, radical act of existing in an environment where gravity does not pull fluid away from the head. For the Artemis II crew, this process was monitored with extraordinary precision. The mission carried ophthalmological monitoring equipment that allowed ground-based physicians to track changes in the crew's visual systems throughout the flight. The data collected during that mission represents some of the most valuable information ever gathered about the acute phase of spaceflight-associated neuroocular syndrome. The earliest hours and days of its onset, the rate at which intracranial pressure responds to the removal of gravitational fluid distribution, the individual variation between crew members in how quickly and how severely the condition develops, because it does not develop the same way in every body. This is one of the most important and least discussed facts in human spaceflight medicine. The human body's response to the space environment is not uniform. It varies between individuals in ways that cannot be predicted with current models, that do not correlate cleanly with any of the measurable baseline parameters: age, fitness level, cardiovascular health, body mass index, prior spaceflight experience. Some astronauts develop significant visual changes after a few weeks in microgravity. Others show minimal changes after 6 months. The reasons for this variation are not fully understood, and the inability to predict which individuals will be most affected represents one of the most significant open questions in the science of human spaceflight. For a mission to Mars, a journey that would take 7 to 9 months of transit in each direction, followed by a surface stay of potentially 500 days or more, in a radiation environment significantly more severe than low Earth orbit, and a gravitational field too weak to prevent the full development of a microgravity-related physiological changes. This unpredictability is not an academic concern. It is a mission-critical problem without a current solution. The Artemis program exists, in part, to generate the data required to approach that problem. Every measurement taken on every Artemis crew member is a data point in the largest, most consequential medical study in human history. The study of what happens to a biological creature from Earth when it leaves Earth and stays away long enough for the planet's absence to become physiologically legible in the tissue and the bone and the fluid and the nerve. But the body's response to space is not only structural. It is not only the measurable mechanics of fluid shifts and bone density loss and muscle atrophy. All real, all documented, all significant, all pointing in the same direction, which is the direction of a body that is being slowly unmade by the removal of the conditions that made it. There is something happening at the level of the genome, inside every cell of every human body, coiled into the nucleus with a precision that makes any human feat of engineering look casual by comparison, is approximately 2 meters of DNA. The molecular instruction set for building and maintaining a human being. a text written in a four-letter chemical alphabet that encodes roughly 20,000 genes. Each gene a set of instructions for producing a specific protein, each protein a functional component of the biological machinery that keeps the cell alive and performing its specific role in the larger organism. This molecular text is not static. It is dynamic in ways that were not understood until the relatively recent emergence of the field of epigenetics, the study of how environmental conditions alter which genes are expressed and which are silenced, without changing the underlying sequence of the DNA itself. The genome is not a fixed blueprint. It is a responsive document, annotated in real time by the chemical consequences of the environment the body inhabits. Temperature, nutrition, stress hormones, light exposure, social interaction, physical activity, all of these conditions leave molecular marks on the genome, turning genes on or off, amplifying or suppressing their expression, shaping the biological behavior of cells in ways that can persist for years, and in some cases, be transmitted across generations. The space environment leaves marks on the genome. This was demonstrated with extraordinary precision by the NASA Twin Study, a longitudinal research project that followed astronaut Scott Kelly during his year aboard the International Space Station, while his identical twin brother Mark Kelly remained on Earth as a genetically matched control subject. The study, involving dozens of research teams and thousands of individual measurements, found changes in gene expression patterns in Scott Kelly's cells that did not appear in Mark Kelly's. Changes in genes related to immune function, DNA repair, bone formation, cognitive processing, and telomere length. Most of these changes reverted toward baseline after Scott Kelly's return to Earth. But not all of them. Approximately 7% of the observed gene expression changes persisted 12 months after his return, suggesting that extended spaceflight had induced alterations in his cellular biology that were not fully reversible by re-exposure to the terrestrial environment. 7% sounds small. It is not small. 7% of the human genome is hundreds of genes, hundreds of biological processes, hundreds of molecular conversations between cells that change their language in response to the experience of space and did not fully change it back. The Artemis II mission was shorter than Scott Kelly's year in orbit, but it was conducted in a radiation environment dramatically more severe, at distances from Earth that placed the crew outside the protective bubble of the geomagnetic field, in a trajectory that exposed them to the full spectrum of galactic cosmic radiation and solar particle radiation, without the shielding that even the relatively thin atmosphere of low Earth orbit provides. The biological data collected from the Artemis II crew before, during, and after the mission is still being analyzed. The full picture of what the deep space radiation environment did to those 4 genomes, what marks it left, which genes it touched, which molecular conversations it interrupted or initiated, will take years to fully characterize. But the preliminary findings are significant enough that they have altered the planning assumptions for future long-duration deep space missions. Because here is the thing that space radiation does that distinguishes it categorically from the radiation environments encountered in medical imaging or even in nuclear industry work on Earth. It does not arrive from one direction. On Earth, radiation sources have locations. You can shield against them by placing material between yourself and the source. The lead apron in a dental X-ray room works because the X-ray machine is in front of you and the lead is between you and it. Galactic cosmic radiation arrives from every direction simultaneously. It is the accumulated output of every supernova, every neutron star merger, every active galactic nucleus, every violent astrophysical event that has occurred in the observable universe for the past 13.8 billion years, distributed through the interstellar and intergalactic medium by the magnetic fields of galaxies and the expansion of space-time itself, arriving at the location of the solar system from all directions at all times, with an intensity that the heliosphere, the bubble of solar wind that surrounds the solar system, partially attenuates but does not eliminate. Beyond the heliosphere, in interstellar space, the galactic cosmic ray flux is approximately 4 times higher than it is inside the heliosphere. Inside the heliosphere, but outside Earth's magnetosphere, which is precisely where the Artemis II crew was during the trans-lunar and lunar flyby phases of their mission. The flux is significantly higher than in low Earth orbit, and the particle energies are high enough that conventional spacecraft shielding provides limited protection. The most energetic galactic cosmic ray particles pass through aluminum, through polyethylene, through the densest shielding materials currently practical for spacecraft construction, with only modest attenuation. They pass through the hull, they pass through the seat, they pass through the suit, they pass through the skin, the fat, the muscle, the bone. They pass through the nucleus of cells, and sometimes through the DNA coiled inside the nucleus. And when they do, they can break both strands of the double helix simultaneously. A double-strand break, the most severe form of DNA damage, the type that the cell's repair machinery finds most difficult to fix correctly, the type most likely to result in a mutation if repair fails, the type most associated with the cellular dysfunction that, accumulated over years, expresses itself as cancer. Every hour spent in deep space, the body accumulates radiation dose. Every hour, the cosmic ray flux passes through the genome. Every hour, the molecular text that defines a human being is read by particles from the far reaches of the universe. And occasionally, not always, not even frequently in absolute terms, but with a statistical regularity that compounds over time into something that cannot be ignored. A particle leaves a mark. The Artemis II crew accepted this. They understood the numbers. They signed the consent forms written by the space medicine teams that quantified the risk in the dry, careful language of probability and confidence intervals. They understood that their mission would add a small but real increment to their lifetime cancer risk. They understood that the data their bodies generated during the mission would be used to refine the models that will determine how future crews are protected on longer, deeper missions. They accepted this in the way that the first people to sail across an unknown ocean accepted the possibility of falling off the edge of a world that turned out not to have an edge. Not with certainty about what lay ahead, but with the specific courage of people who understood that the map ends here and chose to go anyway. This is perhaps the most human thing that has ever happened in space, not the technology, not the engineering triumph of a capsule that keeps 4 people alive in an environment designed to kill them by every available physical mechanism, not the navigation, not the life support, not the communication systems or the trajectory calculations or the tens of thousands of hours of labor by tens of thousands of people on the ground whose names will never appear in any headline. The most human thing is the acceptance, the willingness to go to a place that will change you at the molecular level, that will reach inside your cells and leave traces of its passage in the most intimate biological record you possess. And go anyway. Not out of ignorance, not out of recklessness, but out of the specific, unreasonable, magnificent human conviction that the knowledge gained is worth the cost paid. Every scar the universe left on those 4 bodies is a data point. Every altered gene expression pattern, every elevated radiation dose, every subtle reshaping of an eyeball by the fluid dynamics of a body in microgravity. Every one of these biological consequences is information. And information in the hands of a species that has decided to leave its planet is the most valuable substance in the cosmos. More valuable than gold, more valuable than any resource that has ever been fought over on the surface of a world that its inhabitants have not yet learned to leave. Because the information in those bodies will help the next crew go farther. And the crew after that will go farther still. And somewhere in the chain of missions that begins with Artemis and extends forward into a future that none of us will live to see in its fullness, a crew will use the accumulated biological knowledge of every mission that came before them to travel to a place so far from Earth that the sun itself will be just another star, bright nearby, familiar by comparison to the others, but a star, just a star, one among hundreds of billions in a galaxy that is one among hundreds of billions in a universe that may be one among an uncountable number of universes whose existence we can infer mathematically, but will never, in any scenario that physics currently permits, directly observe. The body that makes that journey will carry, in its genome, the molecular memory of every body that came before it, including the 4 bodies that flew around the moon in the early years of the 21st century, and came back changed in ways they are still finding language for. The cosmos left its fingerprints on them, and they left their fingerprints on the cosmos in return. That exchange, that mutual marking, that reciprocal alteration between a biological creature and the physical universe it inhabits, is not a metaphor. It is the oldest story there is. There is a frequency the universe broadcasts,